short, logical model. Before that, we have studied conceptual model in chapter 2 and chapter 3. The conceptual model is starts with the requirement analysis of an organization, uh, uh, and then converting those requirements into business rules, and later on making an ER diagram or an enhanced ER diagram. The ER diagram or enhanced ER diagram shows the entities, the attributes each entity has, and the relationship among those entities. But the conceptual model or the ER diagram cannot be translated directly into a physical database design, which means that if I have an ER diagram and I want to implement a database in any database engine, for example Oracle or MySQL or Access, etc., I cannot implement it directly by using the ER diagram, because ER diagram has some information missing in it. For this purpose, we make a logical database design based on our ER diagram, and once we have the logical database design ready, then we can implement the logical database design or the logical model into any physical database design. Basically it means that if I have a logical database diagram, I can implement it directly into any database of my choice. So in this chapter we will see how we can transform our ER diagram into a logical database design. So basically in logical database design we make a relational model. So a relational model has three components. First is the data structure, second is data manipulation, third is data integrity. Data structure means how the data will be structured in our database. In other words, how an entity in an ER diagram will be structured into a relation. We will see it in shortly that how we do it. Data manipulation means all the operations that can be performed on data, like we can add data to a relation, we can modify data in a relation, we can delete data from a relation. So these are three basic operations that we apply on our data, and for applying these operations we have a standard language, SQL, standard query language or structured query language, through which we apply these operations. Last component is data integrity in the relational model. Data integrity is basically a set of rules to ensure that the whatever data we enter in our relation is valid and consistent. So let's start with the first component, which is data structure. So a relational data structure is basically a relation. A relation is a representation of data in a tabular form or two-dimensional representation of data, which means that we have named columns in our relation. Each column represents an attribute in our entity, and then we have arbitrary number of rows in each relation. Arbitrary number of rows means each row represents one single record in our entity or of our entity type, and we can have as many rows as required. Let's say I have a relation by the name student, and the named column inside the relation can be registration number, name, father name, etc., and each row in that relation will represent one entity instance or record of one particular student. So let's say registration number 123, name Hamza, address Lahore, again registration number 124, name Adil, address Karachi, etc. So this is how we store data in a relation. Here an important point is that each record or data that we store in a relation is not part of the relation. Part of the relation means it is not part of the structure of a relation. As I have just mentioned, that the record of each student stored in a student relation is the data stored in the relation, but it is not part of the relation, which basically means that it is not part of the structure of a relation. The relation of a structure determines the number of columns in the relation and the attributes of those columns, that is the name of the column, the type of data that we can store in a column, and so on. We will see about the properties of columns in a short while. Now the second thing is, in each relation we have relational keys. Basically there are three types of relational keys: a primary key, composite key, and a foreign key. So a primary key is an attribute which uniquely identifies a row or a record in a relation. A primary key is a necessary requirement if we want to insert, update, or delete a row or a record in a relation. For example, if I want to delete a student record, then I must know the registration number of a student, because a registration number uniquely identifies a student record. Let's say if I write a query to delete a record on the basis of a name, I may delete many records in addition to the one that I want to delete. Suppose I say that I want to delete a record of a student whose name is Hamza Khan, and in our university we have around 24,000 students. So there is a high probability that we have more than one student whose name is Hamza Khan. So if I issue this query, I may delete all the record of all the students whose name is Hamza Khan. So this is not what I want. To avoid such problems, we always use the primary key as a criteria for deleting a record. Similarly, we always use primary key as a criteria to edit a record. Let's say a student named Hamza Khan, whose registration number is 124, comes to me and says that his address has changed or his phone number has changed, and he asks me to update his address or phone number. So if I issue the query on the base of primary key, which is 124, only the address of that particular Hamza Khan will be changed. But if I execute a query on the basis of name of the student, then I will change address or the phone number of all the students whose name is Hamza Khan, which was not required. So that's why whenever we create a relation, we always identify a unique identifier or a unique attribute inside a relation, and we make that attribute or make that column a primary key. A composite key is also a primary key, but the difference between a composite key and a primary key is a primary key has only one column in it, which means it is made up of only one column. But if a single column cannot uniquely identify a record or a row in a relation, then we look for a combination of more than one column names or attributes that can uniquely identify a record or a row in a relation. So let's say if a combination of two columns or three columns, or in short more than one column, uniquely identifies a row in a relation, that combination of two columns or three columns will be called a composite key. So in short, a composite key is also a unique identifier that uniquely identifies a row in a relation. But the difference between a composite key and a primary key is a primary key has only one column in it, while a composite key has more than one column in it. A foreign key is simply a primary key of one relation that is written in another relation just to make a relationship between the two relations. Again, I will repeat, a primary key or a composite key of one relation that is written in another relation is called a foreign key, and we create foreign keys to actually build a relationship between the two relations. uh, like we have studied in ER diagram, there are one to many relationship, one to one relationship, many to many relationships. Those relationships are physically implemented by adding foreign keys in the related table. Now here is an example. There are two tables, employee and department. The employee table has attributes employee ID, name, department name, salary, and the department table has department name, location, and fax number of the department. Here department name, which is the primary key of the department table, has been written in the employee table here. Now this department name in the employee table is called a foreign key, and this foreign key references the department name in the department table, and this foreign key is written here to make a relationship which is one to many relationship between department and employee. A foreign key is represented in a diagram by a dashed underline. Now here are some properties of a relation. Each relation or a table in a database has a unique name. Okay, so it means that we cannot create two relation having the same name. This is not allowed, or this is not possible. Second point is very important. An entry at the intersection of each row and column is atomic. Atomic means a value that cannot be broken down into further smaller parts. So in short, a single value or a single valued entry. So basically it is saying that value at the intersection of each row and column should be atomic. We can see it through an example. Okay, this is an employee table having attributes employee ID, name, department name, salary, course title, and date completed. Now intersection of each row and column. So this is a row and this is a column. The intersection of this row and this column has only one value, 100. So it follows the criteria mentioned in point number 2. Here again, at the intersection of first row and name column, we have a single value here. Again in department name we have a single value. At salary column we have a single value. However, in the course title column, for this row we have two values. One is SPSS, the other one is survey. So this is this doesn't follow the criteria mentioned in point number 2, which says that at the intersection of each row and column there should be a single value. Here we the cell should have a single value, but in this cell we have two values instead of one value, so we have to fix it. Same is the case here. In the date completed column we have two values in first row and date completed column. If we see this row having employee ID 110, this row again has two values in the course title column and two values in the date completed column, and same is the case with employee ID 150. In course title we have two values and in date completed we have two values. So there is a problem here and we have to fix it problem. Anyway, we will see how to fix it. So again, an entry at the intersection of each row and column is atomic. There can be only one value associated with each attribute on a specific row of a table. No multi-valued attributes are allowed in a relation. So in short, while making ER diagrams, we can mention an attribute as a multi-valued attribute by writing its name inside the curly braces. But while mentioning a relation, a multi-valued attribute is not allowed. So we have to remove it, and we have to fix it. We will see in a short while how to fix this. This is an anomaly. We have to fix it. Now, point number 3: each row is unique. No two rows in a relation can be identical. So it means we cannot duplicate a whole row. In other words, let's say if I have an employee with ID 100, I cannot write this record again in another row. Like employee ID 100, name Margaret Simpson, department name marketing, salary 48,000. So I cannot duplicate a whole row. Each row should be unique. Point number 4, each attribute or column within a table has a unique name. Just like a row, we cannot repeat a column. We cannot have two columns named employee ID. Similarly, we cannot have two columns named employee name, etc. And if we take an example of a student relation, we cannot have two columns by the name registration number or by the name student name or student phone number. There should be only one column for one particular attribute. Point number 5, the sequence of columns is insignificant. Okay, so the order of this column is insignificant. I can write it like name, employee ID, department name, course title, salary, date completed. Their order doesn't matter. So we can write the columns names in any order we like. The sequence of rows top to bottom is insignificant as with columns. Okay, as with column name, same is the case with the records or rows that we store in a relation. Like if I store this row first, whose employee ID is 150, and then I enter the row 110, then 190, then 40, it doesn't matter. We can enter the records in any order. So you have to keep this in mind, that while creating a relation, you should follow these 6 rules.